This is a video of a 3D animation on the mismatch repair pathway in E. coli. In the cytoplasm is the E. coli's DNA, the molecule that contains all of its genetic information. DNA is made up of nucleotides, each of which contains a phosphate sugar backbone and an organic base. The two strands of DNA are held together by hydrogen bonding between complementary base pairs. Adenine pairs with thymine and cytosine pairs with guanine. DNA mismatches occur during DNA replication. For simplicity, this animation will show DNA as a flat molecule. Before replication can begin, a helicase needs to unwind the DNA molecule. In E. coli, DNA polymerase III catalyzes the incorporation of new complementary bases to the new DNA strand. This is only the alpha and beta units of the DNA polymerase III enzyme. However, it is possible for DNA polymerase III to incorporate a non-complementary base to the new strand. This is known as a mismatch. A mismatch could result in a faulty protein being coded for, so it needs to be repaired. The first step in the mismatch repair pathway in E. coli is recognition of the mismatch by the mutS homodimer. mutS recognizes the mismatch and binds to it. Then the mutL homodimer binds to mutS, ready for a later step in the mismatch repair pathway. Meanwhile, up to a kilobase away, the mutH protein recognizes a GATC site. mutH is a weak endonuclease, which will create a backbone incision between the guanine and adenine residues on the newly synthesized strand when activated. mutH is able to differentiate between the newly synthesized strand and the template strand by the lack of methylation markers on the newly synthesized strand. This is why the pathway is also known as methyl-directed mismatch repair. In order for mutH to become activated, it needs to bind with mutL. This causes the DNA to bend. The newly formed backbone incision allows an exonuclease to enter and begin excising nucleotides from the newly synthesized strand. The exonuclease excises the mismatched nucleotide and stops excising just beyond it. Now, DNA polymerase III can begin to resynthesize the new strand, inserting the correct complementary base where the mismatch used to be. The final step is for DNA ligase to ligate the backbone nick. The mismatch pathway is now completed, and all the newly synthesized DNA is complementary to the template strand.